Okay, so I want to button up this little series of videos using the different trig things trig identities to solve for pieces of triangles and properties of triangles. And let's go on to area. This may be a little longer video, but you can fast forward over the pieces that you don't need. I'm going to start by just finding the area of triangles using either just a simple formula about areas, and then I'm going to go into Heron's formula, which is only using side lengths. And we'll kind of take it from there to end up talking about what happens if you want to deal with polygons instead. So we'll start here with what the formulas are. So we have a series of formulas, and these formulas are predicated on the idea of having known side angle side. So in a triangle like this guy right here, where you have sides A, B, and C, one of the formulas says that the area of a triangle is 1/2 A times B times the sine of C. So notice A, B are here, and C is right in the middle, A, B, C. So that's a side angle side, like I said. Now we can restructure it and say AC, but again, it's side angle side. So if there's A and C, then B would be the angle in the middle. Or last but not least, if we said BC, then the sine of angle A. A would be that angle in the middle. Now, this is actually very, very useful to solve triangles involving just this setup right here. So a really nice, easy problem would be one where maybe we said you got 11 inches, you got 15 inches and 104 degrees. Maybe we'll make this BAC. So we're actually using this rendition of the formula right here, that the area of that triangle is 1/2 the product of the two sides times the sine of the angle in the middle. And it's literally that easy. And I just have to poke numbers in my calculator. So I just need to take 11. Actually, I did start with 0.5 times 11 times 15 times the sine of the angle in the middle. And I just found out that I messed up. 0.5 times 11 times 15 times the sine of 104. And I've got that the area of this triangle is 80.05. I think I did this in inches, so this would be inches squared, and it's literally that easy. That's amazingly simple. Now, sometimes you're not so lucky as to have SAS given. Maybe someone was a little bit more mean and they gave you an AAS, where you had, say, maybe this angle right here is 25 degrees. This angle over here is 53 degrees, and this side over here is, let's say, 12. Well, unfortunately, I don't have side angle side. I don't have enough information. So what we're going to have to do is a little bit of work first. So I'm going to start by taking 180 degrees, take away the 25 and the 53 that I know, and I know that that's 102. And again, I put that in red because that's new information that I don't have. Now what I'm going to do is I'm going to use the law of sines and say the sine of 25 over 12 would be the sine of, let's say, 53. Again, I guess I'll just make up some letters here, over C. Now I can do just like we've done in previous videos. I'm going to cross multiply and do a quick division. So this would be 12 sine 53. Can't see that off of the calculator. 12 sine 53 divided by the sine of 25. And I just found that letter C, little c, is 22.676. That's 22.676. Now, as I said earlier, or 677, I guess, would be a better one. And so if we have side angle side, and if you kind of follow what just happened, we have a side, and there's the angle right in the middle. So to find the area of this triangle, I had one extra step, but I just need 1/2 the product of the two sides times the sine of the angle in the middle. And I could have picked a different angle in the middle. I could have maybe found this side instead, and it's no big deal. So I'm going to take 22 actually wrote 12, didn't I? 22.677 times 12 divided by 2. I've got all of this, and then times that by the sine of 102. And it looks like the area of this triangle would be 133. Now, as it turns out, there's one other formula that we have. And that was, it's called Hero's formula, or sometimes known as Heron's formula. And it's a special formula that's using this letter S, which is A plus B plus C divided by 2, which is called the semi-perimeter. And what it is it's only used for side triangles. So it's very limited. There's only certain ways that we would use this. And that formula says that the area would be a big, huge square root. It's really a large one. You would take that S that you got, and then you'd multiply it by the difference of S and side length A and B and C. So not as useful as the other ones because you have to have everything perfect right out the gate, but it's still pretty nice. So let's imagine, if you will, that we had the following pieces of a triangle. I had a 10, a 7, and a 9. Those are just 3 random numbers. If I go in here and I add them together, 10 and 7 and 9 makes 26. So I divide that by 2, and I have a semi-perimeter of 13. So the area of this figure would be the semi-perimeter 13 multiplied by 3, because that's the difference between it and 10, and the difference between 13 and 7 is 6, and the difference between 13 and 9 is 4. And so this is quite literally our final answer. But if we wanted to simplify that a little teeny bit, we could actually break these pieces down into their, I guess we could call it their prime factorization, although there's other ways to do it. I got a pair of 3s and a pair of 2s, so I have 6 outside, 6 roots of 26 units squared, and that would be how to find the area of a side triangle. And that will kind of finish this video. Now, we could use it to solve some polygons and things, but that will be done in a separate video. All right, you guys have yourself a good day, and I'll see you back.